Welcome viewers. Today we are going to discuss a topic from your course Kinematics and Dynamics of Mechanism, which is DME 020 of your third year of mechanical BTech Mechanical Computer Integrated Manufacturing. In this topic we have already covered the basics of kinematics and dynamics of mechanism, in which we have already discussed what is theory of machines, what is kinematics. Today we will start from the basic with the definition of theory of machines, because the kinematics and dynamics of mechanism is also called as theory of machines. This is very important subject for mechanical engineering student, because it deals with the various types of motion due to various types of forces acting between the different parts of machine. So if we see the slide, that what is the definition of a theory of machine, it's basically is a branch of engineering science which deals with the study of relative motion between the various parts of the machine. That means this subject is dealing with the various types of motion which exist or which comes between the parts of the machine parts due to the various forces acting on the parts. If we see that what is the machine, basically it is a transformation. It takes the energy in some form and converts into the useful work. Therefore we can say that it is a device which receives energy and transforms it into some useful work. The most important part of the characteristics of the machine is that it consists of a number of parts or the body, which we called as a link or the element. Now another important terms which comes in the theory of machines, which I am again telling you, that is the rigid and the resistant body. In this subject, whenever we talk about the element or whenever we talk about the bodies, they are mostly rigid body or the resistant body. Our body is said to be rigid if there is no relative motion between the 2 points, or the distance between the 2 points remain constant whenever the force is applied. Similarly, the resistant bodies are those which are rigid for the purpose they have to serve. That means in our practical life it is possible that we are not able to get the resistant body, but in our all purposes we take care or we take the rigid body as the resistant body, because in this we can neglect any deviation or any movement, relative motion between the two parts. Similarly, a link which we are studying here need not to be a rigid body, but it must be resistant body. That means that it is resistant, it is rigid for the purpose for which we have taken it or for which we have considered it as a rigid body. Similarly, a body is said to be resistant if it is capable of transmitting the required forces with the negligible deformation. Now we will come to another definition, that is called the kinematic pair. When kinematic pair is formed when two links, remember here the two links means two rigid links or the elements of machine are in contact with each other, provided the relative motion between them is completely or successfully constant or fixed. We can classify kinematic pair into three categories. One is lower pair, another is higher pair, and third is wrapping pair. Now if we see that what is the lower pair, basically it depends upon the contact between the two meeting surfaces. When the connection between the two elements is through the area of contact, that means there is a surface contact between the two links, the pair is called the lower pair. If we take the example, then example of slider in the cylinder, or the piston in the cylinder, or the motion between crank pin and the connecting rod at the big end in your slider crank mechanism, these are the examples of your lower pair, because in all these examples there is a surface contact between the two links. Now when we define the higher pair, then the surface contact is a point contact or a line contact, and we have example of cam and failover. You just see this point, this is a surface, it is not a surface contact, but it is a point contact or a line contact. So here we are getting the point contact, so therefore it is a higher pair. Wrapping pair comprises the belt and chain and other drives, and it comes from one side of pulley to the another side of. Such type of pair is called the wrapping pair. Now comes the kinematic chain. It is an assembly of linkages, or you can say that when the kinematic pairs are coupled, then they form the kinematic chain. When one link is connected with another, another one is next link, and the last link is connected with the first link, then it is formed the kinematic chain. Now we take the example of the different types of pair which we have discussed recently. This is a slider crank mechanism. Here you are piston, cylinder, this is your connecting rod, then this is crankshaft. So the crankshaft of engine form a kinematic pair with the bearings which are fixed in a pair. The connecting rod with crank forms a second kinematic pair. Similarly, piston with the connecting rod form the third pair, and the piston and the cylinder form the fourth pair. And the total combination of this link is known as kinematic chain. Now every link or every chain cannot be called as a kinematic chain. There is some rule which we have to follow, and if the chain satisfies this rule, then this chain is called as a kinematic chain. Here is one of the rule, that if each link is assumed to form two pairs with the two adjacent links, then relation between the number of pairs, that is P, forming a kinematic chain, and the number of links L, expressed in such form that L is equal to 2P minus 4. If any chain satisfies this condition, that means left hand side is equal to right hand side, then we can say that this kinematic chain or this chain is a kinematic chain. Second condition is that number of joint, there is a relationship between the number of joint and the number of links, that is J is equal to 3 by 2 divided by 2 into L minus 2. If they satisfy these two conditions, then we say that the chain is a kinematic chain. Now we take the example of a 3-bar mechanism or 3-bar chain. Here link AB link, then link 2 is BC, and link 3 is CA. So these three links have been joined, and now we have to see that whether this chain is a kinematic chain or not. Now consider this arrangement of these three links. Now here the number of links is 3, number of pair is again 3, number of joint is again 3, 1 joint, 2 joint and 3 joint. Now see that when we put L is equal to 2P minus 4, then you will see that on left hand side L is equal to 3, while on right hand side we are getting only 2. So left hand side is greater than RHS. Let us see the second condition, that is J is equal to 3 by 2 into 1 minus 2. Here L we have taken 3, so again left hand side is greater than right hand side. Therefore we can say that the arrangement of 3 links does not satisfy both the equation. Therefore it is not a kinematic chain, and hence no relative motion is possible, and hence such type of chain is called the locked chain, or it cannot be called as a kinematic chain. Again, now we see the 4-bar link or 4-bar chain. This is your link 1, link 2, link 3 and link 4. Now you just see that if we give the motion to this link, then this motion is transmitted to various other links. So now we will see that whether the 4-link chain is a kinematic chain or not. Now here L is equal to 4 because we have a 4 link. Number of pair is 4 and number of joint is 4. So let us put in the first equation, that is 2p minus 4, and if we put the values on the left hand side we get 4, and similarly on the right hand side we again get the 4. Therefore left hand side is equal to right hand side. This means the condition number 1 is satisfied. Now we will come to the second condition, that is J is equal to 3 by 2 into L minus 2. Again we will put the L, so we are getting this is 6 minus 2, 4. Again left hand side is equal to right hand side. So both condition has been satisfied in the 4-bar or 4-link chain. Hence we can say that this 4-link chain can be called as a kinematic chain. And here the degree of freedom is 1, because the motion or the movement given to one link defines the movement of remaining links or this kinematic chain. So therefore the degree of freedom for such type of kinematic chain is called the 1 degree of freedom. After this discussing about the different type of link, different type of chain, we can come to the mechanism, because once we have already talked about the link. Link is a basic element. When you combine 2 links, then there is a formation of a kinematic pair. When these kinematic pairs are coupled together, they form the kinematic chain. Remember, we have discussed that every chain cannot be kinematic chain. There is a 2 conditions which has to be satisfied. Then only we can say that this chain is a kinematic chain. And 3-bar chain cannot be called or cannot be termed as a 4-bar. So the basic kinematic chain has 4 links. Now this chain, when this chain has a motion, or this chain transmits movement or the force from one end to another end, then it is called the mechanism. So we will see that what is mechanism and how it works. Let us see the slide. That mechanism can be defined as a closed kinematic chain in which one link is fixed. The kinematic chain which forms the mechanism should have the constant motion. So from this definition, you see that in a kinematic chain, when we are fixing one link, then the motion transmitted to one link is transmitted to another link, and we get the useful work. That means that whenever we are fixing one link or one element of a kinematic chain, this is called as a mechanism. And another important definition of the mechanism is that this has a constant motion. It may be completely constant motion or successfully constant motion or unsuccessfully constant motion. Now we will see again the slide that whenever there is a motion of a link, it can be purely rotational or purely transitional. That means it can be linear or it can be rotational. But in our practical life, we always see the combination of both. So now we will see that how these two motions can be occurred simultaneously. Let us see the slide. Now this is a link AB. Now you just see that this has moved to this position, that is A1, B1. Now it has a combination of linear motion as well as rotational motion. Now we will see that how it has reached to this position. First it has a linear motion and then it has a rotational motion. From AB position it comes to A1 B dash position with a linear movement, and after reaching at this point it has a rotational motion. Therefore we can say that the motion of this link about a point can be said as a pure rotational motion. Because it is very difficult to have or to study the both motion simultaneously, we can say that there is a point about which the motion of this link is purely rotation, and this point is called the instantaneous center. This type of study is helpful in analyzing the velocity or determining the velocity of any point in the link or the acceleration of any point in the link. So we can say the combination of rotational and the translation motion of the link AB may be assumed to be motion of pure rotation about some center which is known as instantaneous center. Now there are various methods of determining the velocity of a point on a link. The first method is your instantaneous center method, and second method is called the relative velocity method. Now you just see this method that motion of a body can be considered as a pure rotational about instantaneous center. This is the basic thing, basic philosophy with the help of which we determine the velocity of any point on a link with the help of instantaneous center method. Now we see that this is your body 1, this is your body 2, and this is a link which is in the motion. Now this point has velocity in this direction, this point has velocity in this direction, but if we take this point, then we can say that this link is in a pure rotational motion with about this point. So this point is known as instantaneous center. Now see this figure, that this is a body, this is a link AB, and this is a direction of velocity of point A making alpha degree from the link. Similarly, the point B has a velocity direction with the beta degree from this link. Now I is the instantaneous center. How we have determined, which is the intersection of perpendicular BI and AI. Now we have dropped the perpendicular from about this direction of the velocity, and these two lines intersect at this point, which is known as I or instantaneous center. Now about this point we can say that this link has a pure rotational motion. Now we resolve the velocity along the link. You just see that this is a two components, one along the link, another is a perpendicular to the link. So along the link it is a VB cos beta. Similarly, along the line we have a VA cos alpha. So since these two velocities, since the distance between these 2 points does not change, because it is our basic definition that this is a resistant body, and in resistant body the distance between these two does not change, or there is a negligible change in the distance. So we can say that this velocity of this point, this is only possible when these 2 points have the same horizontal or the velocity along the link. So if we just see that V upon V cos VB is equal to cos beta upon cos alpha, and if you transform it sin 90 minus beta, and if apply Lami's theorem in this triangle ABI, then AI upon sin 90 minus beta divided by is equal to BI upon sin 90 minus alpha. So AI upon BI is equal to this much, and we got the final equation, that is VA upon AI, VB upon BI, or VC upon CI. And you know that this is your angular velocity. Now we will see that what is the properties of instantaneous center. There, in simple word, there are 2 properties. The first property is, which we have studied, that it is rigid link and rotates instantaneously relative to another link about the instantaneous center. And 2 rigid links have no linear velocity relative to each other. So when we calculate the velocity or acceleration with the help of instantaneous center, we have to keep these 2 properties in our mind. Now another properties of the instantaneous center is that the total number of instantaneous center, which is equal to n into n minus 1 divided by 2, where n is the number of links. Now when we are talking about the different properties, we must see that what are the different types of instantaneous center which normally exist in the mechanism. First type of center is called the fixed instantaneous center. Second type of center is called the permanent instantaneous center, and third is neither permanent or nor fixed permanent center. Now with the help of one example we will see that what is the fixed instantaneous center, what is permanent instantaneous center, and what is neither permanent or nor fixed instantaneous center. So we are taking the example of a 4-bar mechanism, and here the total we can say is 4 links. So it is your link 1 which is fixed, and when a kinematic chain one of the link is fixed, it is called as the mechanism. Now we have this 4-bar mechanism. It is your ABCD, and this link, this AB link and this link, since this is link 4 and this is link 1, so the interaction between these 2 links is our first instantaneous center, that is called the I14. Similarly, the instantaneous center exists between the intersection of link 3 and 4 is called the I34. The intersection point between link 2 and link 3 is called the I23. Similarly, link 2 and link 1, it is I12. Now these 2 instantaneous center are fixed. They cannot move from this position. So that is why these 2 centers are the fixed center. Just see this center and this center. With the help of this movement, if you give this movement, the position of this center changes. But they are permanent in the nature that they have their position here only. So they are called the permanent instantaneous center, and these centers are called the fixed instantaneous center. Now we since n number of instantaneous center is equal to 6, because it is 4 into 3 divided by 2, so it comes as a 6. So we have 6 instantaneous center. So far we have identified only 4 instantaneous center. So now we have to see that how you will determine the remaining 2 instantaneous center. We extend this line. Similarly, we extend this line and we get the intersection of these two lines, and we get this instantaneous center. Now we extend this line and we extend this line, and we get this instantaneous center. Here you will surprise and you will just observe that there are this link, link 1, link 4 and link 3. Now with the help of these 3 links, we have a 3 instantaneous center, I14, I34 and I13, and all these instantaneous centers are lying in the straight line. Similarly, with the help of link 3, link 2 and link 1, we have a instantaneous I13, I23 and I12, and both are on the same straight line. Similarly, just like see this center I34, I23 and I24, these exist in the straight line. Now as we said that the number of instantaneous center is equal to 6, I12 and I14 is fixed instantaneous center, and I34 and I24, these are the neither permanent nor fixed, because when the position of this link changes, the position of I13 and I24 also changes. So they are called as neither fixed or nor permanent type of instantaneous center. After this, we can see that how we can locate the position of instantaneous center. Just see that when we have a such type of link and they are interacting at this point, then this point is called the instantaneous center, and our instantaneous center, just like if it is link 1 and it is link 2, then instantaneous center I12 will lie on the intersection of these two links. If the two links have the pure rolling motion about the fixed link, then the point of contact, since this is the point of contact, here the instantaneous center will lie. So here it is link 1 and it is link 2. So link 1 and 2 has point contact at this point. So at this point of contact has the instantaneous center I12. If the link 2 or 2 links have the sliding motion, just like see this body has a sliding motion with this fixed link, this is a slider and this is your fixed link, then the instantaneous center will lie in the infinity, because there is no line intersecting within the infinity, so the instantaneous center lie in the infinity. If this sliding motion is in the some curvature, then the center of instantaneous or the instantaneous center lies at the center of curvature. Now we will come to the Kennedy's theorem, which talks about the how you will identify the position of the instantaneous center. So far we have covered that the instantaneous center is a center about which we can assume that the link has the pure rotational motion. And Kennedy's theorem says that if 3 bodies are in the motion, then the instantaneous center of these 3 links lies in a straight line. And with the help of this Kennedy's theorem, we can identify the instantaneous center or the position of instantaneous center in a mechanism. Now we will take the this Kennedy's theorem, that this is a 3 links and which is A, B and C. This is a rotational motion, and due to rotational motion this has a motion here. Now this link B and link A has instantaneous center IB at the intersection. Similarly, the instantaneous center between link C and A, IAC, exists at the intersection of these two links. Similarly, this point IBC is the intersection of link B and C. Now, according to this velocity theorem, the velocity direction of link B is perpendicular to this link. Similarly, velocity for C, since this point lies on the both, so the velocity direction of VBC is also perpendicular to link C. Now here you see the contradiction, that the velocity, the magnitude of velocity is same for VBC, but the direction, if it exists on link B, it is perpendicular to B, and if we assume it is in C, then it is perpendicular to C. So that contradicts our initial proposition. Hence we can say that if 3 links A, B, C are transmitting motion, then the instantaneous center of these 3 links will lie in a straight line. Now we will come that what is the method of locating the instantaneous center. As a first step, you have to first calculate what is the number of instantaneous center with the help of this formula. Suppose the number of links is 4, then total number of instantaneous center is 6. So this is the first step while determining or while locating the instantaneous centers in a mechanism. Similarly, we have to make the list of all the instantaneous center in a mechanism. Suppose we are calculating the 4-bar mechanism. So just see, we have put here 1, 2, 3, 4, and for link 1 we have an instantaneous center I12, I13, I14. Similarly for link 2 we have a 23 and 24, and for link 3 we have a I34. So in all we have a 6 instantaneous center. This table will help you to identify the number of instantaneous centers in a mechanism. Now after that you have to locate first the fixed and the permanent instantaneous center. Suppose we have a, by inspection you can easily locate where the fixed and permanent instantaneous centers lies. After that you can locate the permanent instantaneous center. Suppose we have a link, this one 4-bar link, so we can see, we can just draw a circle of any radius and we make this 4 or rectangle. If we have a 4-bar, then we can cut into 4 parts, rectangle, or you can say square. If we have a 5-bar, then it should be here pentagon, or in case of 6-bar it is a hexagon. So you just see that we have located here 1, 2, 3, 4. This tells you the number of links. It is link 1, link 2. So if we have already located the instantaneous center between 1 and 2, this is a firm line. So this is telling you about this instantaneous center. The instantaneous center between 2 and 3 we have already calculated, this one, so it is firm line. Similarly 1, 4 and 3, 4 is also firm line. Now you have to determine the instantaneous center 1, 3 and 2, 4. So 1, 3 lies between instantaneous center 1, 2 and 2, 3 and 1, 4 and 3, 4. So when you extend the line joining instantaneous center 1, 2 and 2, 3, so this is your point 1, 2 and 2, 3. you have to extend this line. Similarly, you have to extend the line joining instantaneous center I14 and I34. So when you extend this line, they are intersecting at this point, and this will tell you or locate you the instantaneous center I13. Similarly, when you have to locate the instantaneous center I24, you have to extend the instantaneous center I12 and I14. This means this link should be extended. Similarly, link 2, 3 and 3, 4. This instantaneous center 3, 4 and 2, 3. The line joining these two centers should be extended, and the intersection point of these two extended lines will be the instantaneous center I24. So in this way you can determine or you can locate the instantaneous center in a 4-bar mechanism. Now this is one of the example of calculating or locating the instantaneous center. You just see this is another 4-bar mechanism example. Here you see that this is a slider, or with the help of this 4-bar, just like this is O to A, B and E. So when you are extending this line, you are getting this center I24, and when you are extending these two lines, you are getting this instantaneous center. The most important part is this circle. This circle will help you in determining or in locating the instantaneous center in a very complex situation, because otherwise it is very difficult, because when the number of chains or number of links increases, the whole system becomes very complex. So this helps in reducing or minimizing the complexity and helps you in determining or locating the instantaneous center. Here, with the help of this instantaneous center, you can also calculate or determine the velocity of links. Here your AF link has a rotation of 100 rpm. So you can convert into the angular velocity in the radian per second by multiplying by 100 into 60. Now this 100 is your distance between F and A. So with the help of this you can convert it into radian per second. Now this is your angular velocity, and if you know the distance between the point and the instantaneous center, you can easily calculate the linear velocity of this point. So here we have calculated the instantaneous or the linear velocity of point A, because we know the distance between instantaneous center. This instantaneous center lies here I12, so the distance between this point and this one is your calculated, and with the help of this we can calculate the linear velocity of point A. Similarly, angular velocity of link AB we can find out. That is, we have to find out the angular velocity and then the distance between this instantaneous center and this point. So with the help of this we can calculate the velocity of various points in a link. This is another example of a slider crank mechanism, which is also a 4-bar mechanism. I have taken this example because in this certain instantaneous centers are different from the previous examples. Here you just see that this link has a sliding motion, so their instantaneous center is lying at infinity. That is the link 4 and the link 1. So between these 2 points the instantaneous center is lying at the infinity, and remaining instantaneous center, suppose this is your link 2 and this is your link 3, so the intersection point is this one, so I23 will lie here. Now you just see that I23, 2 link, 3 link and 4 link, these are the 3 links. So the 3 instantaneous center will lie in the straight line, therefore I24 will lie by extending this line, and wherever it is cutting the line going through the infinitive, telling the instantaneous center I14, and this point is called the I24. Similarly, this interaction or intersection between link 1 and 2 will give you point I12. Here we have again calculated this, determined the value of I13, that is your I13, this point. The distance between this point and this point we have determined with the help of a scale, and it comes at 460 millimeter or 0.46 meter. So velocity of a slider, this one can be calculated with the help of this instantaneous center. So far we have discussed about the determination of velocity in a mechanism with the help of instantaneous center method. Instantaneous center method, when we talk about instantaneous center method, we have to know that what is instantaneous center and what is the method of determining the instantaneous center, because it is a very simple method, but the prerequisite is that you should know the method of determining or locating the instantaneous center in the mechanism. This method becomes very complex when the number of links or number of chains increases. We have seen the 4-bar mechanism. Even a 4-bar mechanism, this calculation or the location becomes complex in a complex mechanism. So we have also discussed about the Kennedy's theorem, that when there are 3 links, so their instantaneous center will lie in a straight line. The best way to determine the instantaneous center is to form a matrix, and then we have to find out that what would be the different types of instantaneous center. And there are 3 types of instantaneous center. One is your fixed instantaneous center, second is your permanent instantaneous center, and third one is neither fixed and nor permanent instantaneous center. When we talk about the fixed center in a 4-bar mechanism, when we are fixing one link, then this intersection between the fixed link and the moving link is the fixed instantaneous center. So in next section we will talk about the relative method of determining the velocity, and we will also see some of the examples of this instantaneous center method, and we will try to explain you these 2 methods. Thank you.